Hey guys, welcome back to this course. In this particular topic, we'll be exploring the concept of attractor points and Voronoi in Grasshopper 3D. So as you can see, we'll be actually creating a geometry like this. So I'll just go to set view and select this particular geometry so that I can pan around properly in my Rhino viewport. And as you can see, you'll actually be creating something like this, where these particular Voronoi cells are more saturated on the outside and it has a very wide space on the inside. The cells are smaller, and on the outside the cells are more bigger. You can actually create this kind of a gradation, and you can actually parametrically control it using all of these number sliders. So you can increase and decrease this whole thing. You can also change the count to something like this. You can also change the seed, which changes the way the cells are organized and the cells are arranged like this. And you can also change the location of the attractor point. Right now the attractor point is somewhere over here. You can change the location and make it something like this, which means I have just placed the attractor point on the corner, so that's why all the other cells are a little bit bigger than this area. You can also change the remapping values, which will create some kind of a different effect on this entire form, as you can see. And you can of course change the height of this entire system like this. So let's go ahead and create this script, and let's understand how the concept of attractor point or a detractor point and the concept of Voronoi works in Grasshopper 3D. So I'll just be clicking on file and clicking on a new document, and we'll be starting this entire thing from scratch. So the first thing that you have to actually bring in is a rectangle. So what we'll do over here is actually we'll create a rectangle on the XZ plane, and after creating the rectangle we'll actually populate it with some points, so then we can generate the concept of a Voronoi. So we can just double click and type rectangle, and you see this particular component which says create a rectangle on a plane. You can click and bring this in. So let's see, you have the plane as the input. It asks for the X and the Y size, and it also is asking for some radius. So let's give it a plane of XZ. You can just type XZ and bring in this particular component. It says world XZ plane. Input it inside the plane, and you will have your entire rectangle on the XZ plane. So now let's turn this off. Select it, use your central click, click on the disable preview option over here, and the plane will be gone. Now you can actually double click and bring in a number slider. And let's change the value of the number slider to, let's change the maximum value to maybe 50. And you can plug it both inside X and Y so that the entire thing is a square, and you can increase the X and the Y size accordingly. So over here you can see the X and the Y are increasing accordingly, and that's exactly what we want over here. You can also plug some radius in, but for now let's leave it just like this. After you're done with this, we can actually populate it with some points. So for that we'll use the populate 2D component. So just double click and type populate 2D. So you see a populate 2D and populate 3D. We'll be using populate 2D because this is a 2D shape. So you plug in rectangle inside region, and now you can actually plug in count and seed. So I'll just double click and type 100. Now if you guys want a shortcut to adding number sliders, you can just double click, and after it says enter a search keyword, you can just type the number that you want to appear on your number slider as the maximum number. So you can just type 100, and you see it automatically gives you the number slider option. So after you type 100, just press enter, and it will create a number slider for you from 0 to 100. So I'll attach this to count, and I'll also double click and create another number slider which will consist of the seed. So maybe I can just double click and type something like 80, and I have another number slider as the seed. So if I keep changing the seed, the location of these points keep getting generated and at random positions, and the count will increase and decrease the number of points in this particular rectangle. So after you're done with this much, now what we can do is we can generate a Voronoi diagram according to these points right here. So you can just double click and type Voronoi, and you will find this particular component which says planar Voronoi diagram for a collection of points. You can click and bring this in. Now in order to understand where this component comes from, you can just press Alt and click on it, so that you can see that Voronoi is actually located under the mesh tab inside the triangulation topic, under the triangulation tab right here. So under triangulation you will find Voronoi right here. This is the one that we are using. So it asks for points, radius, boundary and a plane. So we already have the points, which is this particular output. These are the points that we are looking for. This will go inside your points. After you put it in, you see it automatically creates a Voronoi diagram from the set of points that you have given. But there is a huge problem over here, which is that these lines, we don't need these particular lines which are extruding out of our geometry. So in order to solve this, what we have to do is we'll have to use a component known as region intersection. So we'll actually be intersecting this particular rectangle with all of these extra lines, and we'll only be keeping the lines inside this particular rectangle. So I'll just be double clicking and type region intersection. This particular component, you can actually find it under your intersect tab, so you can just use Alt and click to find it out, and there it is under shape. So it asks for two sets of curves. First set of curve is actually the rectangle, and the second set of curve is actually our cells. After you do that, so it asks for two set of curves. First set of curves is actually your cells, because you actually want to subtract these particular lines from the rectangle. So you actually want to subtract the rectangle from your cell curves. So you have inputted cell in the curve A input, and the rectangle will go inside curve B like this. And now you see you have exactly what you need. You have these particular curves like this, and so now what we can do is we can turn this off and we can turn this thing off, and now we have exactly what we need. So now that we have successfully built the set of Voronoi polygons along with these particular points that we have created, the populate 2D component, you can actually try and see how it affects your entire diagram. You can play around with it and see that if you increase the count, the number of cells increase. If you play around with the seed, the location of the points change, and accordingly the Voronoi cells change their shapes and sizes. Now the next thing that we can do is we can actually use the concept of an attractor point on this entire set of cells. So let's try that out. So for that you actually need to convert this particular rectangle into a surface first, and after converting it into a surface, we'll actually be creating a point on that surface, which will be terming as the attractor point or the repulsor point, depending on what kind of domain we give to it. So you can just double click and type boundary surfaces, and you see the boundary surfaces component. We have seen this under our surface tab. You have the boundary surfaces right here under freeform. So you can use the boundary surfaces component, plug your rectangle output inside edges, and you will have a total surface that you can actually now use to find your attractor point. So after you are done with this, now let's use the evaluate surface command that we have seen in the previous topics and create a random point on our surface. So you can double click and type evaluate surface, and now we already know that we have to reparameterize this surface so that we can move around the point freely. So you can right click and click on reparameterize. You can attach this inside surface, and you can double click and type in MD slider, which is a multi-dimensional slider. We have already seen this in the previous topic. Bring in an MD slider, decrease its size a little bit, and attach it to point. Now you see you have a random point that you can move around on your surface anywhere you want to. So this is exactly what we need. Now since we have this surface created and this random point created, now what we can do is we can use the closest point component to actually calculate the distances of each of these points from this particular point. So we'll actually be calculating the distances of this point from every point that we have. And according to those particular distances, we'll actually be scaling the size of these cells. And that's how we create an attractor point concept. So let's go ahead and do that. So you can just double click and type closest point. Have the closest point component. We have already seen this in the previous topics where you actually get the distances of the closest points. So you can actually plug in your population output, this output, inside your point component, inside your point input, which is basically the point to search from. Now you have to be clear about something over here. As you see over here, you have the point, and some of you might be thinking, why didn't we attach this particular output? Because this gives the point output and point should go inside point, right? But actually, if you see, if you keep your mouse icon on top of point, it actually tells you point to search from, which means what point should you search from this entire group of points, you know, and the group of points are coming out from here. So the points that you need to input in order for this particular component to search from it, it's asking for that particular input. So you have to input the group of points inside point, and inside cloud you'll actually have to input this particular point, because if you keep your mouse on top of it, it will actually tell you cloud of points to search. Now we don't have a cloud of points, we only have one point to search, which is this particular point. So this will go inside cloud. Now you see, you'll actually get distances of all of these points from this single point on this particular surface. So now what we can do is, now we can directly scale, we can attempt to scale all of these cells according to these distances. So you can just double click and type scale. Bring in the scale component. So the scale component, you can actually find it under transform and under affine. Under transform and affine, the transform tab, you can actually find your scale component right here. So it asks for three things. It asks for the geometry that you want to scale, center of the geometry that you want to scale, and the scale factor. So let's input those three things. Geometry that we want to scale is right here. These are the cells that we want to scale. This will go inside geometry. As you see, when I plug this in, it automatically takes in the center as this point and scales it down automatically. But that's not what we need. We actually have to input the centers now. So the centers of all of these cells are actually right here in population. These are the centers of all the cells. So this goes inside center. Now you can see that every cell is being scaled down from its center by some specific scale factor. But the scale factor is empty over here. We can't see any number attached to this, but if you keep your mouse on factor, you see it already has a default scaling factor of 0.5, which means every cell is being scaled down to half its size according to these as their centers. So let's double click and type in a number slider to use as a scale factor just to see how it works. So you can just double click and type 2.5 or 2.3. Attach it to factor. You see now you are actually increasing the size of the cells, so that's why it's a mess. So what if you decrease it? Now you see you have actually decreased it, and 0.6 gives you this much, 0.4 gives you this much. So you can just double click and change its maximum value to 1. So it's on a scale from 0 to 1 now. So 0 actually gives no output, because this thing turns red, and it actually tells you cannot scale with factor 0. You cannot scale a geometry with the factor of 0. If you increase it a little bit, and there you go, you have some progress right now. So you can actually scale all of these. Now what if I want to scale all of these things according to the distances that I have received from my closest point component? I have received a lot of distances, right? All the distances from this particular point to all the other points. What if I want to scale these cells according to those distances? Let each of those distances be the scale factors. So if I want to do that, I can just plug in distance inside factor. So I'll just delete number slider and I'll plug in distance inside factor. But if you do so, you'll actually find something like this happening. And this is because the distances have numbers which are out of the bounds, which means if I double click and bring in a panel component, attach a panel to it, you see that you actually need to have numbers between 0 to 1, but all these numbers have some other values. It has 15, 12, 18, 24. They are very high. You actually need to remap these numbers from this domain that it has. I guess the domain is from 3 is the least, the smallest number that I can find, and the largest number that I can find over here is, I guess, 25. So it has a domain of 3 to 25. You need to remap that domain of 3 to 25 to 0 to 1. So over here we'll be actually using the remap component. So I'll delete this panel. I'll disconnect this particular factor from distance. So in order to disconnect a wire, you can just right click on disconnect and select this till it turns red and click on it, and you will be able to disconnect your wire.